All right, for number 2, same directions as number 1. We need to see if this fits the mean value theorem. And for that to happen, remember it has to be continuous on the interval, and it has to be differentiable on that interval. So from -2 to 3. So first, looking at this function, you should notice that this is not going to be continuous at all points. Whatever makes this denominator 0 is not going to be part of the domain and could be either a whole or an asymptote. So here, x cannot equal positive 2. If we put 2 in here, we get 5 divided by 0, which is undefined. So this is not continuous on this interval. So we can't use the mean value theorem. It's not going to work if there's any type of discontinuity, a hole, asymptote, jump, anything. In this case, remember, we end up getting an asymptote. If this x minus 2 were to cancel out with an x minus 2 on top, that would represent a hole, but here we have an asymptote. So it's not continuous. That means this is not going to be, it's not going to satisfy the mean value theorem. So look at that first before you start doing a derivative and setting up the whole problem, because you're just wasting your time by doing that. So always kind of take a quick look and see, is it continuous and is it differentiable? So with this one, if we had a different interval here, if we were going from, let's say, -5 to 0, that would be okay, because this discontinuity would not be in that interval. If we used just that interval, we'd be all right. We'd be able to use the mean value theorem and find an x value where the instantaneous rate of change is the same as the average rate of change. But in this case, since this falls within this interval, it does not satisfy the mean value theorem.